In this example, we would like to evaluate the indefinite integral of e raised to the power square root x, all divided by square root x. Now, in order to evaluate this, let's just note that we see this kind of key form that we are looking for, this function derivative pair. You have the square root x appearing inside the exponential function, and then appearing outside of that exponential function, you have this 1 over the square root of x. So that's not exactly the derivative, but it is up to a constant multiple. And this is an indicator to us to try the substitution u equals the square root x, so that du would be 1 over 2 square root x dx. So rewriting our integrand, just a bit differently here, we could write this as e to the square root x times 1 over square root x dx. So to get everything solely in terms of the variable u, we see that the square root x in the exponential is going to become the u, and then the 1 over square root x dx is going to become 2 du. So putting this solely in terms of u, it's the antiderivative of e to the u du, and we'll go ahead and put the 2 out front. A nice simple antiderivative for us to evaluate. So 2e to the u plus c. And whenever we're evaluating an indefinite integral with a substitution, our last step is to take those u's and write them in terms of the original variable x. So resubstitute back in, this is 2e to the square root x plus c. Now, an important observation to make is that when evaluating indefinite integrals, one always does have the ability to double check your work. How do we double check our work? Well, what we need to see is that the solution we came up with, when we differentiate it, what we are going to get back is the integrand that we started with. So differentiating via the chain rule in the first term, we take the derivative of the outside function, which is e, evaluate it at the inside function, multiply it by the derivative of the inside function, and then plus the derivative of c, which is just 0. The 2's cancel, and we have exactly the integrand that we started with, e to the square root x over square root x.